Alright, so welcome back to another day of Advent of Code. And today I haven't decided yet on what language to use. I still have some suggestions like using Common Lisp or LLVM intermediate representation, which just by looking at the example input, I think maybe not today because honestly I hate the 2D ones because every time I did them, it was either Haskell or some other weird language, and yeah, I mean 2D arrays are a pain if you don't have for loops and real arrays. So I mean I know it's only day 6, but should we just use the Python card? I'm not sure. Let's read through the description first, and then we'll actually make up our mind because maybe it's something really simple, maybe it's something like weird. So yeah, let's read through the input and see what it's about. Okay, so let's see. Day 6. The historians use their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab, so with the lab. But the problem is it's year 1518, whatever, maybe not a problem. And it turns out that having direct access to history is very convenient for a group of historians. So literally, yeah, okay, let's not get lost in the story, but actually find the problem. So some paradoxes. So I guess this is a previous day from 2018. A single guard is patrolling this part of the lab. So, I mean, it's weird that we have to probably avoid a guard, but maybe you can work out where the guard will go ahead of time so that the historians can search safely. So, our puzzle input is gonna be a map. I'm curious what it shows. The current position of the guard. So, probably it's gonna be like, yeah, with the V, caret, and the other characters. To indicate the guard is currently facing up, we have a caret. Any obstructions like crates, desks, like for some reason I can make reactors, are shown as a hash symbol. Then the lab guards follow a specific patrol step. So if they have something right in front of them, they turn 90 degrees to the right, and otherwise they take a step forward. Okay, so for instance here it's gonna go up until this crate or whatever, and then it's gonna turn right, and then again and again and again. Okay, and what if it reaches, so here it's, yeah, it's saying that it's going in the other direction, reaching another obstacle. Okay, now it's yeah, making jokes. Turns right, and here it walks into a wall. This process continues for a while, but the card eventually leaves the mapped area. So if it leaves the mapped area, let's see the puzzle input. Okay, so if it leaves the mapped area, it's gone. And by predicting the guard's route, you can determine which specific positions will be in the patrol path. The positions visited by the guard are marked with an X. And here it says that it visits 41 different positions. Okay, I'm pretty sure for part 2 is gonna be if it goes out of bounds, it's gonna wrap around. But I don't know what the stop criteria will be. Like maybe it's gonna be until it reaches the origin point, and like that's the modulo problem, right? Which usually comes at some point. So like finding the cycle. I think that's what's gonna be. So yeah, as I said, I don't think, like, if we want to make it easy for us, I'm just thinking about yesterday. I mean, Prolog was cool, like the solution was really nice, but damn, it sucked. It took so much time to parse the input, so I wouldn't really try a new language when it's input like this. Like when we have input like day one, where is it? Input like day one. I mean, that's fine. I can do that in any language. I can parse list of numbers in any language, but this one is kind of too much, I would say. So maybe we can just do something like JavaScript. Why not? I mean, JavaScript is, it kind of sucks as a language, so I wouldn't say it's a waste of, wasting a simple language for a easy day. But I'm pretty sure the second part, that's what it's gonna be, right? It's gonna wrap around and you have to walk until the origin point or something like that, and you need to find like a cycle. Yeah, let's see. Let's actually try to use JavaScript. I'm actually also just installed JavaScript in the environment, like in the dev environment, because I was playing around with trying to make like a small animations for each day, but I only did for day one, part one. But it's like, sorting the numbers and then showing the answer. I think that's kind of cool, but I still have to do some stuff with it. But yeah, anyway, let's try to use JavaScript for day 6. Right, so let's see the code. Okay, so day 06. Let me just next run. Let's get the input for day 6, and I guess we should see this big matrix. Okay, and let's try JavaScript because I already just installed everything for JavaScript. So main.js console log, so node. Okay, if we go see day 06, yeah, so I would do again something like input day 06 just to read. So JavaScript like Node.js read from std, because I'm using Node, right? How to read from, oh my god, I forgot I closed the, so read line. I guess we can do, yeah, I remember I was using read line in one of like, oh shit, what, in like a really old project. So pretty sure that's the right way of doing it. So read line interface, whatever, and then online, and that's the end of input. So if we do something like this, let me just, why isn't it format? Anyway, so if I try this, it's gonna, cannot use import statement outside of a module. So it literally wants to use like require and stuff, right? I cannot really use, okay, but it reads the input properly. Right. where is this guy? Okay, so it's here. So I guess my idea, I haven't explained it yet, is to, because it's gonna be going up, going left, right, or down, right? And what I want to do is have a hash map with all the position. Does it matter if it visits the same position twice? Yeah, it matters. So distinct positions. Okay, so what I'm gonna do then is keep track of all the points, of all the turning points that the guard visited, and then we can just generate all of them or something. I don't know, we'll see how we do that, but the idea is we search first on the vertical line on the column until we find the first, that's gonna be interesting, until we find the first obstacle. Or I guess we might as well just simulate everything, because why not, and we'll get fucked by the second part, but that's not a big deal. So yeah, then that input, I only see dots right now. So let's say we want to parse this hash map. So we want to have obstacles, which is gonna be a map, right? I guess I can make it const. Okay, and let row is equal to 0. Well, actually, obstacle is just gonna be an array, if I think about it. An array of positions. Array of positions, right? Yeah. Might as well just be an array of positions, why not? But, if I think about it, if I'm gonna simulate each step, I could just keep a 2D array. So map could be like an empty list, and map dot append or push line. Right, but the problem is, oh, so here, for instance, I can call main, right? And then I have function main, and I give it the map. And I can console log map. Let's see if this thing works. Right, so that's how we get the map. All right. Okay. And then I can have like a parse input function or whatever, but let's see. So function parse input. I'd say this function should probably give us the player initial, like the guard initial position. That's what I kind of want to get. So let's give it the map. Let's give it the map, and I mean, we'll just output the player position in like a list. So let's have for let I is equal to 0, I is less than map dot length I plus plus. It's funny that you don't even have type annotations. Maybe type, I mean, I'm gonna use TypeScript as a separate language just to cheat, so yeah, it is what it is. Sorry about that, but let me just open up Node. And do we have something like find? Find index. We don't have JavaScript string find. It's called search. I mean, it can work, right? So I'm just gonna keep the node open. So can the guy start in any other position? I don't think so. I mean, in my input, I don't see that. Right, I see it's a caret. So and it also looks like it's in the middle of the map. Am I right? Does it say? Not really. Anyway, let's see. So guard position. So we are gonna have let x, let y is equal to -1, let's say, and at the end we just return xy like this. So what would happen if we search for something that doesn't exist? It's -1. Perfect. So I can do stuff like y is equal to map I dot search, and I'm gonna call this thing a row and column. All right, so here we are gonna get the column and I is the row, but that makes sense. So here we are gonna search for caret, and if column is not equal to -1, we are gonna say the column is column, row is I, and we break. Right, so that's the goal, kind of. So then we have let, can I say maybe guard row guard column is equal to guard position map, and then maybe just console log these two variables, guard column 0 0. That's not right. Huh. Did I make mistake already? No, I don't see the search result. Yo, what? It literally said here -1. No way, that's regex. Jesus. Wait, regex actually does it. I mean, yeah, whatever. So we get 59 close and 62. Not sure if that's the middle, but doesn't really matter. So next step is to have also a facing. So let facing is equal to I forgot if you can have an enum in this language. I don't think so. Enum, JS enum. You can have. Let me just close over. Oh, const. Okay, so let's say const up is equal 1, const right is equal to const down, const left 4. And facing is just gonna be facing up, right? And let's have a function guard step guard. Okay, and maybe the guard will actually be like an object. Facing is facing, row is guard row, and column is guard column. So what if we make this thing and we get the guard, or I guess map and guard, and let's just return a new guard or something. So I can say guard is equal to guard step, or maybe I mean that would be kind of annoying to have a class, right? Class guard, and then we can have a constructor which takes in the map, and I say let row column is equal to guard position. So this is just a helper function, gives us a row column, and then I can say stuff like this dot row is equal row, and this dot facing is equal up. And then we can have a step function which just modifies, so let guard is equal to new guard, and I just give it a map. Is it gonna print it nicely though, or is it gonna be, oh nice, perfect. And these ones I can even just make them like this, right? It doesn't even matter what they contain, as long as I just use this this thing. Perfect. So we have the step function now, and step is supposed to just make one step in the facing direction. Let's just look at this beauty again. Okay, so if this dot facing is equal to up, we do some stuff. Wait, we also have switch, which is weird, but oops. Anyway, so if we are facing up, we need something like const new row is equal to this, what am I doing? This dot row minus 1, new column is equal to this dot column, right? So these are the new coordinates that I need to go to, right? But I have is valid a function, maybe it's like private function is valid. What this one is gonna do is gonna take in a row and column, and it's just gonna check if, oh, I forgot to save this dot map is equal to map. It is going to check if the map of the row and column, maybe like this, So it can actually just return that. Return it's not hash. Or maybe, yeah, if it's not a hash symbol, then it's valid. So what I'm gonna do is if this dot is valid, new row, new column, we are just going to set the two coordinates, right? That makes sense. Only TypeScript, yeah, whatever. Only TypeScript can do stuff. And now the interesting question is, what happens if it's not valid? Right? That's a good point. Well, that's gonna be interesting. You know, I'm already about to go into that rabbit hole of, okay, but what if the guard is surrounded on all sides? Well, it's not gonna be. But I was thinking of having a step up function, right? So if step up, so step up is just gonna make this, and I think that if it is valid, facing should become up, right? And let's say we turn, or we have an else, and what should we do on the else is this dot step right? So if we cannot go up, we have to turn 90 degrees to the right, as it says in the problem statement somewhere here, right? And it needs to go right. And basically step right, what is it gonna do is something really similar. Const new row is just gonna be this dot row. Const new column is gonna be this dot column plus one. So reason why minus one is because this is the first line, this is the last line. So up is negative, and right is positive. So this dot is valid, new row, new column, this dot row equal to new row, this dot column is equal to new column, and this dot facing is equal to right. And else we step down, right? So this, I mean, it's gonna handle the cases where it's not necessarily surrounded, but let's say it wants to step up, but it has an obstacle, then it's gonna say, okay, let's step right, but it also has an obstacle, so it has to go down. I mean, I think that's how it's supposed to go. So let's just delete that, and let's try again. So if it's valid, it's going down. Otherwise, it has to go left. So let's take this function, and it's gonna be step left, the last option, and left is negative column. So here it's left, and here we need to step up in case you cannot step to the left. And then step function, as I already mentioned, is if this dot facing is up, then we step up. I think I'm just gonna use something like this. If we are facing right, down, right, down and left. Okay, so that's what step is gonna do. It's just gonna do a single position. Now, interestingly enough, it doesn't really return anything. So maybe we want to return the new position, but that's just this row, this column. So we can just do that here if we wanted to. So I'm just gonna keep it like this. Step, right? And let's have here like for let I is equal to 0, I is less than 100, I plus plus, guard dot step. Let's make it step, and then let's see the output. Let's see if it's working. Right. So step up. Oh, I was like, what? Yeah, I forgot that you actually have to put this. So it does something, which is nice. I don't like that it prints. Okay, let's create a TMP file with this input. Okay, nice. So at some point it just crashes because it's out of bounds, right? And that's kind of where, you know, it also stops here after like 41 steps. So that's pretty decent. It's less than 100. So what I'm gonna do then is have here something like if is bounded row column, or maybe like is leaving. Is leaving. I mean, honestly, is leaving is just when this thing crashes. So we can go full JavaScript mode and just catch this exception, but I don't like that. So we could say something like is bounded row column, and have something like row is less than, or I guess row is greater or equal than 0, and column is greater or equal than 0, and the row is less than or equal to this.map.length, and column actually greater, like less than this.map0.length. So that's when it's bounded. So if not is bounded, return true, I guess. I don't know. I mean, I'm not sure. Yeah, I mean, yeah, I don't know about this one. We can just make it like this, and it just goes out of bounds. We don't care about it. Makes sense. And then can we have another is bounded that just return is this is bounded. Can we have functions like that? And then we can do like while guard is bounded with step, and we can return print the row and column. Let's see. Wait, what? Why is it printing the... Huh. Wait. Row is greater or equal to 0. Yeah, I mean that's true, right? Am I... It's and between all of them. What? Console.log row column. Fuck? How is that wrong? Undefined? Really? That's pretty interesting. Nice. So it's actually printing some positions, but we have to keep only the unique ones, right? Because okay, let's say we do let counter is equal to 0, and we say counter plus equals to 1, and we print the counter. Well, the counter is gonna be 40, which is like plus 1, right? Because of the starting position, but it's not distinct positions. Or is it distinct positions? I guess in this case it might be distinct positions just by chance. Or are they? Like how many x's? Because I don't believe these are 41. What the fuck? 5 and 3. From collections import, wasn't there collections import counter? Shit. S is equal to, and let's say we have the counter 41 x's. Wait, that doesn't really make sense. Like how was it so lucky that it... like it clearly touched the same position multiple times. Huh? That's weird. So we have 1 5. Oh, 1 5, a row 1 column. I mean, something's a bit strange. How is it row 1? Yeah, like column 2, column 4 makes sense, but row 1. Oops. I mean, what can I say? Like maybe this character is not, it's something wrong with it. Yeah, actually it found it. That's impressive. But isn't it like more than 1? How is it 1? Did I copy something? Oh, okay. I copied the wrong example. Okay, so this one. So again, I'm pretty sure it's gonna be more than 41, right? And it even has, like, I don't think it has the starting position, right? So it's gonna be even 46 by that logic. So let me just remove that. So yeah, you can see that it repeats some of the positions, right? We have to remove them. So how can we do that? Is maybe with the dictionary or like a set. Do we have a sets? JS set. I'm pretty sure we have a set. So let steps is equal to new set, and I'm gonna do something like steps dot add guard row guard column. Okay, and then what if we show steps dot length, steps dot size? Interesting. How is it still 45 though? Don't we repeat some of the items? Like 6 4 is repeated, right? But that's not even in the... Huh. Let's actually do something else. Let map2 is equal to... Can I somehow clone? Copy. Just copy object. Like I can do the dot 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 thingy. Or is it structured? Oh, structured clone. Yeah, whatever. So we get the map cloned. Maybe just even call it map. And let's say map guard row guard column is equal to x. And at the end, let's print the new map. Oh, I can just yeah, I mean, I was right with the map tool. Cannot set properties of undefined. Someone lied. Someone lied. I mean, it is cloned. Ah, it's because it's not bounded. Okay, so I'm gonna do it like this then. First we step and then we wait, what? Map 2. Whoa. Why isn't it? Excuse me? Okay, so that works, but it doesn't work to update a string. JS update string value. So like replace at. Is it really a function or you have to define? That's annoying. I mean, I want it to do like this with the substring. So maybe a row or like, yeah, row is fine. Row is equal to something, and then we do row substring plus replacement, which is x, and then a row plus 1, and index is guard column, and then this thing is equal to row. Oh, I mean, I have to do it like this. Right, so we have the x's. Does it look kind of similar though? I mean, it doesn't really look similar. I wonder why. But it's also, the map looks weird. Like it's missing a, like it's missing some stuff. What the fuck? It's missing this character for some reason. How did it read this shit though? Because it's looking so different. I mean, this part looks the same. Then it has, like, then how come? Oh my, oh yeah, fine. It's like, okay, yeah. I thought it's like two columns. Okay. Can I join the map2.join on new line like this? Yeah, I can do that. Nice. So we can see that now it looks like this, right? It looks exactly the same. So I could just count the number of x's inside of this, right? So if we do the Python 3 thingy and then say counter s, we should get 41, right? We get 41. So we can do that. But why isn't the set working? I guess I can say like item. I mean, that's weird. Can I just have guard dot row guard dot column like this? This is ugly, but that's what you have to do in Java. Set 42. That's interesting. I guess I should do the same thing, but it's still okay. It's 41 items. Okay, so I can just say size, right? But it's still bothering me that I have to do like this ugly stuff, and like adding a list doesn't work. That's so strange. But yeah, JavaScript. What can you ask? So that's how we get 41. So can we now get the input? Okay, I have to scroll up through the entire sheet and we actually get 5162. Let's see. Which is the right answer, strangely enough. So let's try to see what part 2 is gonna be like. So for part 2, the historian begin working around the guards so they avoid it. You borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard. Yeah, returning after what seems like only a few seconds, the historian they explain that the guard's patrol area is simply too large for them to safely search. Fortunately, they are pretty sure adding a new obstruction. Okay, so it's different than what I thought. So you need to add a single new obstruction such that the guard is going to be stuck in a loop. I mean, it's close. We need to find the loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all the possibilities for such an obstruction. Oh. There are only 6 different positions. Okay, I mean, imagine like what we could do. Also, the loop can be... Oh. Yeah, that's pretty interesting. It's kind of hard. I think about it. So we need to find how many different positions could you choose for this obstruction. Well, I'd say that clearly it means that we cannot really use the same simulation as we did for part 1 because it's gonna be too slow, but we can try, right? We can try to brute force. What if we put the obstruction here, here, and so on, like in all the places? But you can see that in here it's creating a loop. Like it creates some kind of loop, right? So here it goes up, down, bum bum bum, to right. In the end it's becoming a loop. It doesn't, I was thinking it's gonna be like a weird, and then it's a loop in the end. Yeah. So it doesn't matter where the loop starts. We just need to have a loop starting, and then it repeats itself once. And we can try to brute force it. Do you think it's gonna work if we try to brute force? No clue. So let's say here part 1, just to have like part 1 done. Wait, what do I print? Printing something. Yeah, we don't need the map too. I was just playing around with it. So part 1, right? It's pretty fast. It makes me think that maybe we have a chance of brute forcing. So yeah. Clearly a better solution would probably be, as I said in the beginning, you move not step by step, but up until the first thingy. So yeah, let's see. I mean, we can have something like step outside, and it does this right here. It walks until it steps outside. This dot step, and then return steps size. Or I guess it returns, yeah, I mean the step size, sure. Or what if we had like a list? But yeah, whatever. Let's keep it like this for now. So that's step outside. Let part 1 is equal to guard dot step outside. And can I do maybe like structured clone guard? So we actually don't lose the initial configuration or something. Or I guess we could as well just have something like this. For part 1. And then for the second part, I would like to get all the positions where we have dots and try to replace them with a hash, and then initialize the guard as usual, and then something like is cycle or something on the guard, like is cycle. Right, so how can we do that? Well, I would have again steps, but this time it should be an array, right? While this dot is bounded, if it somehow exits, then it's clearly false, right? If it's not bounded. And here we have this step, and steps dot push, and I just push this dot row, this dot column. Like, yeah, let's just try to brute force this one. Let's see how it goes. So is cycle, right? We push the steps. How would we check if we have a cycle? We just repeat some suffix, right, in the array. So for example, if we have position 1 2 3 4, and then again 2 3 4, right? That's the idea when we have a cycle. But what if you have at some point 4 4? I mean, that's also a cycle. Pretty sure about that. So we just need to have the same suffix multiple times. Right, so a function is repeating is gonna have an axis. How can we do this one? Is repeating. I mean, I don't see a solution in anything else than n squared for is repeating. Right? I mean, this thing repeats itself if at any point you are in the same like position and also same facing, because if it's same position and same facing, it means that you already went through the same spot again. So then what I'm actually gonna do is maybe steps is still a set, but this time instead of putting only the row and column, we also add this dot facing, because if you think about it, if we are in the same position with the same facing, it means that clearly we are gonna go through the same path. So if steps dot has item, return true, right? Because it means that we got the same place as we were before. So if you continue from here, you're gonna get the same place again. So it doesn't really matter what the cycle looks like. It's kind of, yeah, let's see. So this is cycle. So now what should we do here? Is function a placeable position, give it a map, or I guess placeable positions. Let p is empty list, or let I is equal to 0. Map length. So this one is like a row. And then we have another 4 for the column. Column. And here it's like if map row column is equal to a dot, then it means that ps.push row call. So these are gonna be the placeable positions. We can do something like let part2 is equal to placeable positions map. I don't like that. I have to return ps. I want it to go like functional. So we map, and here we get a row and column. Can we reduce? Doesn't matter. Reduce previous current. So accumulator and x, and we do accumulator plus x. And what if we print like, what if we return 1? Let's see how many there are, right? How many placeable positions do we have? God damn. 16,000. So we could brute force. I think it's easier to just brute force the advent of code solution, right? We try 8,000 first. Then if it's working, we try, if it says it's too low, we try 12,000, and we do binary search. And I think it's gonna be like, what, 15 attempts or something? Like it should be pretty small number of attempts if we try to just brute force the answer. And I'm pretty sure it's gonna take much longer to brute force a solution like this with this one. So let's see. I mean, I could do map to, I have to clone it, right? Otherwise we destroy the map. And then I have to say something like line is equal to map to of row, and then map to of row is equal to line dot substring. What is it? Yeah, substring 0 column plus hash plus line dot sub string of column plus 1. All right, and then I can say new guard map2 is cycle, and like if is cycle then 1 else 0. But I have to return 1, return 0. Let's see if it's actually running. Okay, let me just put an index here. And I'm gonna do something like console log index. Let's see how fast it is. I mean, it's pretty fast though. It was only 16,000, right? Is it this the answer though? It says 6 for the first part. Oh, so it actually worked to just brute force. It's actually surprising. To be honest, I wasn't expecting brute force to work. But I mean, it's super slow, right? And I'm curious what the... so actually, let's see. So what was the... I mean... Oh, actually, yeah, we can see it. What was the answer here? So if I'm doing Python 3, so I mean, actually we solved it, right? So that's... but I'm curious. What's the middle point? So we would have tried 8,000, right? So this is the first step. Then it would say it's too big, so we split by half again. This is the second attempt. It would say, okay, it's too big again, so we split by half again. Too big. This was the third attempt. Split by half. It is actually too small, so this was the fourth attempt. And what are we gonna do now is go between these two. So we have to do this plus, right, and divide this one by 2, and we get too small again. So what we have to do is go between 2007 and 1505, right, and divide by 2. Too small. So this was the sixth attempt. So we do binary search again. I mean, I should have written the algorithm to try this one. We get this seventh attempt. Let's see, we are pretty close. How many attempts would it have taken? Interestingly enough, this one is too big. So it's too big, but it's the 8th attempt. So because it's too big, we have to do binary search now between 1, 1 and 1, 9, 1, 4, like this. Well, it's so close. So now it's still too big. So we have to do between this and 1912. This was, it's too small. So we have to do between this number and 1912. So this is a tutorial on how binary search works. Okay, so it's still too small. Nice. And then 1912, we split by half. Is it? No, it's one more. So this is the 12th attempt. And 1912 12 divided by 2, it's gonna say it's too big, 13 attempts. And I mean, it's obvious that, you know, this one was too small, this one is too big, so I don't even need to say it's, so it takes 14 attempts, at least for my case, right? That's how many attempts it would have taken, knowing that this is the maximum and 0 is the minimum. But obviously I can optimize more and say, okay, let's say that it's not gonna be smaller than 5,000 and it's not gonna be bigger than 12,000 maybe. Oh, I mean, I wanted to say it's maybe not gonna be more than 5,000 or something, because it's clearly less. But yeah, like, would have been much faster by just guessing. So yeah, I guess that's it for today. We actually managed to solve it in JavaScript. The reason why JavaScript is mainly because I didn't want to deal too much with the for loops. But now that I look at the solution, I realize that, well, I could have just created a hash map with the positions, and yeah, like it would have worked, right? You can just see that what we had to do was pretty easy. So yeah, but who knows, maybe like, from what I know, at least Haskell doesn't have hash maps, so that sucks. But I mean, we could have done something similar, right? But I just know that common Lisp is similar to Haskell, so I'm going to assume that it doesn't have hash maps as well. But yeah, that was day 6, so it was decent. I mean, yeah, as I said in the beginning, I don't really like the problems with mazes and stuff like that, the 2D arrays. But yeah, that's gonna be it for today, and we'll see next time.